Hello friends, today we learn how can we find the maximum or minimum value of functions of two variables. Here the example is show that the minimum value of u is equal to xy plus a cube bracket 1 upon x plus 1 upon y is 3a square. Here we have to find the minimum value of the given function u, and u is the function of two variables x and y, and we have to show that the minimum value of u is 3a square. So first we write here the given function u is equal to xy plus a cube times 1 upon x plus 1 upon y. First we find here partial derivatives of u with respect to x and y. So the partial derivative of u with respect to x. Here we differentiate u partially with respect to x, so y is constant here, and partial differentiation of x with respect to x is 1 here, plus a cube is the constant, and here when we differentiate 1 upon x with respect to x, we get here minus 1 upon x square. And when we differentiate 1 upon y partially with respect to x, we get 0 because y is constant with respect to x here. So this will be 0. So this is equal to y, and this plus and minus multiplied minus gives a cube upon x square. So this is the partial derivative of u with respect to x. Now we find the partial derivative of u with respect to y. So we get here del u upon del y. Here when we differentiate xy partially with respect to y, so x is constant here, and differentiation of y with respect to y is 1. So here x is plus a cube is the constant. Now we differentiate 1 upon x partially with respect to y, so this will be constant. So differentiation of 1 upon x with respect to y is 0 here, and when we differentiate 1 upon y partially with respect to y, we get minus 1 upon y square. This becomes x here, and this plus multiplied by minus, we get minus here a cube upon y square. So first we find here the partial derivatives of function u with respect to x and y. For finding maximum and minimum value, we put del u by del x equal to 0 and del u by del y is equal to 0. So we write here for maximum or minimum, for maximum or minimum value, we put del u upon del x is equal to 0 and del u upon del y is equal to 0. So here del u by del x is y minus a cube divided by x square is equal to 0. Similarly, x minus a cube upon y square is equal to 0. Here we put partial derivative del u upon del x equal to 0 and del u upon del y is equal to 0. So now we solve this. So we get here y is equal to a cube upon x square and x is equal to a cube upon y square. Solving this, we get x square y is equal to a cube and xy square is equal to a cube. Now we subtract these two equations, so we get here x square y minus xy square is equal to a cube minus a cube. Taking common here, x xy. So we get here x minus y, and here is 0. Now the value x is 0 here, y is 0, and x minus y is equal to 0. So we get here x equal to 0, y equal to 0, and x equal to y. If we take x equal to 0 and y equal to 0, we get a is equal to 0 from above equation. You can see here, if we put a is equal to 0 in above equation, this x square y is equal to 0. Here we put x is equal to 0 and y is equal to 0 in this equation. So we get a cube is equal to 0. So a is equal to 0. But this is not possible. Here a cannot be 0. When we put x equal to 0 and y equal to 0 in the above equation, we get a is equal to 0. But a is equal to 0 is not possible. So we take x equal to y. Now we take x equal to y. Take x equal to y and put in the above equation in place of x. So x square y is equal to a cube here. We put x equal to y. So we get y cube is equal to a. From here we find out y is equal to a. When x equal to y, so we get y is equal to a. So x will be also equal to a. So one point we find out here a comma a. So first we see here the given function u is function of two variables x and y. So first we find the partial derivatives of u with respect to x and then with respect to y. After that, for finding maximum or minimum value, we put del u by del x equal to 0 and del u by del y is equal to 0. When we put del u by del x equal to 0, we get one equation x square y is equal to a cube. When we put del u by del y is equal to 0, we get another equation x y square is equal to a cube. Now we solving these two equations, we get x equal to 0, y equal to 0 and x equal to y. When we put x equal to 0 and y equal to 0, we get a equal to 0, which is not possible. So we take x equal to y and put in the above equation. We get y cube is equal to a cube. So y is equal to a. Since x equal to y, so x equal to also a. So the point is a comma a. Now we find the second order derivative of u partially with respect to x and y. So we find del u upon del x. We denoted del u upon del 2u by del x2 by r. So when we differentiate del u by del x, again partially with respect to x, so we get 0 plus 2a cube divided by x cube. So this will be equal to 2a cube upon x cube. Similarly, we find here t, which is equal to del 2u by del y2. When we differentiate partially with respect to y of del u upon del y, we get 0 plus 2a cube upon y cube. So this becomes 2a cube upon y cube. Now we find the partial derivative of del u upon del y with respect to x. So this can be written as del by del x of del u upon del y. So when we differentiate del u upon del y partially with respect to x, we get 1. So here you can see r is the second order partial derivative of u with respect to x. When we differentiate del u by del x partially with respect to x, we get 2a cube upon x square, x cube. Similarly, here t is the partial derivative of u with respect to y, del u upon del y with respect to y. T is the second order partial derivative of u with respect to y. When we differentiate del u upon del y partially with respect to y, we get 2 cube upon y cube. Now we differentiate del u upon del y with respect to x partially, we get s. And when we differentiate del u upon del y partially with respect to x, we get 1 here. Now we find the values of r, s, t at the point a comma a. So r is equal to 2a cube divided by a cube, we get 2 here. T is equal to 2a cube divided by a cube, we get 2 also, and s is 1 here. Now we find out rt minus s square here. So r is 2 here, t is 2 here, and s is 1 here. So this is 4 minus 1, this is 3. So rt minus s square is equal to 3, which is greater than 0. So rt minus s square is greater than 0. And here r is equal to 2, which is greater than 0. So r is 0, greater than 0. When rt minus s square is greater than 0 and r is greater than 0, then u is minimum at the point a comma a. Here you can see that when r is positive and rt minus s square is greater than 0, then u is minimum at the point a comma a. Now we find the minimum value, so we put this point in the given function. So the given function a comma a multiplied by a plus a cube and 1 upon a plus 1 upon a. For finding the minimum or maximum value, we put the point in the given function. In place of x and y, we put a. So we get here, this is a square, and here you can see that this is 2 by a. So this a is cancelled out here, a square. So a square plus 2a square, this is 3a square. So the minimum value of u is 3a square. You can see that when we find the maximum or minimum value of functions of two variables. So first we find the partial derivatives of the function with respect to x and y. After that we put del u by del x equal to 0 and del u by del y is equal to 0. We get the two equations. Solve these two equations and we get some pair of points. Now we find r, t and s. R is the second order partial derivative of u with respect to x. T is the second order partial derivative of u with respect to y, and s is the second order partial derivative of u with respect to y then with respect to x. And substitute the given points in r, s, t. Now we find RT minus S square. If RT minus S square is greater than 0 and R is also greater than 0, then U is minimum at that point. When we substitute that point in the given function, we get the maximum or minimum value. Thank you.